In section 14.2, we learn about the Baxter arms joints and the joint states topic. The Baxter robot arm is a 7 degree of freedom arm. It consists of two shoulder joints, S0 and S1, two elbow joints, E0 and E1, and three wrist joints, wrist 0, 1, and 2. For all of these joints, we have a pattern of beginning with a pan or rotating joint, followed by a tilt joint. That happens in the shoulder, the elbow, and then in the wrist we have a rotational wrist 0 joint, a tilting wrist 1 joint, and a second rotating wrist 2 joints. This is true of both arms. Additionally, the head can also rotate or pan side to side. If we want to know the state of all the joints of the robot, we can access the robot joint states topic, in which we can find information about the joint angle position, the joint angle velocities, and the joint torques. It's also interesting to look at Baxter using RViz and a TF display. In doing so, we see that there are many interesting frames on the robot itself. The key ones to pay attention will be the torso frame. You can see the red axis coming out of the robot right here, and the blue axis representing the axis of rotation right here, although it is hidden inside the robot. The other one is placed here on the end effector. For the right arm is called the right gripper, and it'll be a solution for forward kinematics when we want to grasp something with our fingers. Something to note is that for this 7 degree of freedom robot, we do not have a spherical wrist. Spherical wrists are points at which all the wrist axes intersect in the same point, W0, W1, W2. For this reason, we won't be able to derive exact inverse kinematic analytic solutions, but we will be able to approximate. This will be covered later in the chapter. So let's take at the topic robot joint states. We can do that with Ross topic echo, and this is in fact joint states. And before I do that, maybe I will show you the entire list of topics. There's quite a number of topics being printed out by Baxter, including 3 cameras, some gazebo topics, many button topics, some end effector topics, some head topics, many controller topics for all the joints on the right and the left arm, and then a few other joint state topics as well. So if we use Ross topic echo joint states, robot joint states, we'll see that we are printing the names of the joints, starting with the head, followed by the fingers, left gripper finger, left finger joint, left gripper, right finger joint, then followed by the elbow on the left arm, the shoulder on the left arm, the wrist on the left arm, and then repeats for the right arm. We'll get the joint angle positions for all of these joints, followed by the velocity and the effort. If we want to look at the type, we can do a Linux pipe, followed by Ross message show. Sorry, I need to do a Ross topic type. Actually, the Ross topic type for the joint states is a simple sensor messages joint state that you can see right here. And so we found how the Ross topic publication or echo looks like. So let me give you some hints at how we can manage such a difficult topic in terms of viewing simplicity. So if I want to clear the screen every time I want to see this result, I can provide an option. In fact, you can access the helper menu to learn about how to clear the screen, how to apply a numerical width to the numbers, how to do an offset in time, or perhaps how to print just a limited number of messages. So if I say Ross topic echo C robot join states, this will clear the screen every time that I publish something. Now those numbers are very long and hard to read, so if you just want to read to a certain limit in terms of significant figures, you can use the width option. So here we're getting 3 figures, 0.0. If we change that to 4 figures, you'll get these two decimal places and some locations. And change that to 5. Another thing that we can do is just print a subtopic of joint states. So you might be interested in just looking at position. So if you do that, here you just get the full vector of positions. The reason these numbers are not changing significantly is because the robot arm is not moving. And the real arm, you'll have some more jerk in the arm and so some more noise. In the simulation, you can't see it unless you have many significant figures, and this is due particularly from the dynamic of the controller. Then again, if you only want to see a particular joint, you can also include it like this. So I hope that is useful. You can do that with names, with velocity, and with effort.